All right, Heather, take it away.
Thank you all for joining us for this 2021 Student Symposium Continuing Education Seminar titled Building Flood Resilience. Before we get started, please let me share a few technical instructions with you. If you're having any technical problems, please visit Zoom support at support.zoom.us or type your question in the chat box. The recording of this seminar without permission from ASCE Texas section is prohibited. All participants are muted throughout the duration of the seminar. If you have questions, please type them into the chat box in your control panel. Questions will be addressed at the end of the seminar. Now, let's enjoy this short message from 2021 Student Symposium Advocate, the Texas Concrete Pipe Association. Now, I am pleased to introduce our presenter, Doug Conan, a principal at Walter P. Moore. Doug has over 25 years of experience in civil site development across the world. His focus has been on private site development, municipal, state, and federal engineering projects. He also serves as an expert in litigation cases that focus on civil site engineering related to drainage and pavement. Doug has made numerous presentations related to pavement, drainage, and soils with how they relate to site engineering design. Doug is a disaster relief professional who has been part of teams prior to and after major storms, such as hurricanes, ice storms, and major floods. He is a registered professional engineer and an Envision sustainability professional. Doug and I have worked together at Walter P. Moore for several years. He's passionate about his work, and I'm sure he's got an exciting presentation to share. Thank you, Doug, for being here today. Please begin your presentation when ready.
All right, guys, we're going to be focusing on flood protection today. I'm going to tie it in with resilience. So we're going to start talking about resilience. And with resilience, I love this picture. I found this a couple of years ago from the National Academies. Resilience, when you think about it, it kind of depends upon geography. Where are you? So if you're over in the coast, then you're paying attention to flooding, you've got hurricanes, those kind of things. But if you're in Colorado,
Doug, sorry to interrupt. Are you sharing your presentation? I'm not seeing it, or maybe it's just me.
No, I'm not. Pardon me. There we go. Pardon me.
Okay, I see it now. Thank you.
Right. So now you can better see. So resilience really depends upon geography. So in some of the coastal areas, this is more hurricane zone, and obviously you're concerned about flooding. But as you go up in these regions now, Dallas, Oklahoma, so forth, now you're worried about tornadoes, wildfires in New Mexico, Colorado, Utah area. And then, of course, we've got mudslides, earthquakes, those things out on the West Coast. So resilience really depends upon where you are geographically. Now it's not moving. There. So when we're trying to define what is resilience, and you could see what Webster's definition is for resilience, and really it's the recovery and the ability to go and get and bounce back from after a disaster. That's really the focus for resilience. And if you have not seen a Wordle before, this is what a Wordle is. So you ask a number of people a question, what do you think this is? And they'll write down the answers to what they think a particular topic is. So when people are asked resilience, these are the words that they go and they use to define resilience. And the more often that they use a common word, the bigger it is. Also, different industries, they have their own determination for what they feel resilience is. And so you have ASCE, it's very infrastructure focused. AIA, theirs is more, it's talking about the ability to plan, prepare for, and absorb, and they say recover and successfully adapt to adverse effects. AIA is the architects. Then you have RDI. RDI has theirs, and they're talking about the capacity to be able to adapt to changing conditions and maintain and regain functionality and the vitality in the face of stress and disturbance, and resilience design for the design of buildings. And then Urban Land Institute, they've got their own definition as well. And you could see that there's a number of different groups, and each of them have just a slight different take on what they see resilience is, but it's really a common theme, the ability to bounce back or stop something from happening. And that's where we're going with flood protection resilience. There's a lot of different ways to go and handle flood protection. I'm going to give you hopefully an in-depth understanding of what it really means. It's not just building a wall and prohibiting water from coming in. There's a lot of different ways that you can go about it, and I hope you guys learn a little bit. So per FEMA, you can see what they're saying, what they're really looking for out of this. And so, of course, it's trying to go and reduce the loss of life, and then property, because there's so much that FEMA is going to pay to replace and restore. And so the more that we can go and take that out, the better it is for FEMA. I like in situations to be able to go and in presentations to go and ask the crowd, what do you think the causes are for a flood? But here you're going to get the answer key. So of course, there are going to be storm surges, major events, and major events like named storms or 100-year storm, 500-year storm, so forth. Flash flooding. Flash flooding, you may hear it from time to time. It's not that you're having a major storm coming through like a 100-year storm, but you might have a 100-year storm in a very small area, like a neighborhood, or just a very intense storm that the inlets, the local inlets, aren't able to go and handle it. So because they're overwhelmed at that moment, that means that the area around it is starting to flood. It doesn't mean that the streams and tributaries are all of that is flooding, the floodplain is flooding. It just means the inlets can't handle it. And so now, because the inlets can't handle it, the water is just going to keep rising until the rainfall starts slowing down at the capacity of those inlets, and then it starts going down. And there also could be, oh, there's a misspelling there, but there could be nearby local inlet blockage. So you could have great drainage around you, but all of a sudden, if there's something that goes and covers in that drain, that inlet now it has the less capacity, so less ability for it to go. And so we're trying to go and help our clients when we're talking about flood resilience and flood protection. All these various things are things that we have to worry about. And we've discussed these with our clients, which ones are the greatest concern. And of course, we're telling them the ones that we feel are the greatest concern for their location. And there could be a number of other contributing factors. The groups that could go and best benefit from flood protection, of course, hospitals, because those are major emergency structures. Schools, those are often places that are considered places of refuge. Colleges, universities, same thing, places of refuge. Museums, theaters, and of course, campuses. All of these are areas that we have already provided flood protection in the past and are currently. And you'll notice campuses, I'll get into a little bit of that, because that's not an individual site or an individual building. How do you do flood protection for an entire campus? I'll give you some information on that towards the tail end of the presentation. So now we need to understand the different types of flood protection. Do you want to have an active system that you have to go and activate yourself? Or do you want to be passive? So if it happens at 3 o'clock in the morning, you don't have to be out there to go and actually lock it into place and have it work. So I'll give you some examples. So here's active flood protection. In the tunnels of downtown Houston, we've actually done some design, and these are submarine doors. You'll see they have major rubber gaskets along the sides. This is really to prohibit any type of water coming in within the tunnel system. And here's another example of the tunnels. I believe this is in the theater district portion of downtown Houston. And this is where the door actually is. You might not notice it if you're just a standard pedestrian walking by, but that's what these are. And you have to go and actually lock these into place and engage them. Over here is an example of a parking garage, and you have to go and lock this one into place. So there needs to be a person to physically go and do that. You can spend your hundreds and thousands or millions of dollars to go and put in your best flood protection strategies, but if there's not somebody there to engage them and it's an active design, it's not going to do anything. So you have to keep that in mind when you're trying to go and determine your types of flood protection and way you wish to go and do it. And here's some other examples. And you can see this is a down ramp area into a building, like a loading dock. And here's an 18-wheeler in the background. And they want to make sure that area, the basement, doesn't flood because that's the easiest way for water to come in. So here's showing how to activate and lock that into place. And you can see some other examples as well. Does anybody see the active flood protection on this one? This is at a school. And with this one, we call it a guillotine type of flood door where it's actually hidden up in the roof. And you go and activate and bring that down. Now this one, the flood protection is only needed to be just about 18 inches here. So this is flood protection right here. And then they lower the gate down in here to the entrance because you can't have that wall there permanently because it's an entrance. All of these are examples of active flood protection. So at this school, again, somebody has to be there before the flood, hopefully, activate that, bring that guillotine door down to make certain that the flood protection measures are set in place. Now, passive flood protection. The flood protection that you have so that you don't have to be there to activate it. Well, here's one simple example, and that's a flood wall. Sometimes we're providing flood protection. You don't have to go and provide a significant amount of flood protection. And you can see here, this is about a 6 to 8 inch curve. And that's all that was necessary for this location. But it could be devastating if it weren't there because of the amount of flow that could go down into the basement area. Other passive flood protection. Now this one I think is very fun. This, you'll see construction debris in the background. We had not yet tested the flood protection measures that we had designed, and it was scheduled the following week to go and actually test them. And then there was a major storm that came through. This is a downgrade ramp to a loading dock once again. And in this one, this is a flood gate. And the way that it operates is water goes into an inlet that's in the front of the gate. The weight of that water actually activates the floodgate. And so as the waters rise, so does the gate. But of course, the gate is always going to be slightly higher as it's rising to activate, slightly higher than the water. Client was very happy that they went and they hired us to go and design this and get it constructed because it obviously proved to save, it actually did. And you can see in these instances, look on this side, this is the dry side of that same loading dock, and you can see the floodwaters on the other side. And so it was a superb test, and we didn't have to go and worry about testing it after that point. But this again is another example of passive. You don't need to be there. That inlet is there, the water goes in, and it starts to activate again just by the weight of water. It pushes that floodgate up. And here's another example of a parking garage, another floodgate example. And so this was during Hurricane Harvey, and significant waters that are coming through here. And you can see it was activated and it's starting to rise at this point. Here it's fully active. Now there is a little water on this side because, as you know, with sometimes if you're standing underneath an awning or a roof, that you can get some sideways rain coming in. So you will have a little bit of that over there, but I think they'll handle just a little bit of that water and just be able to broom that off compared to the amount that could have gone into that parking garage. And this is another flood wall on the backside of the parking garage that we also designed. So at entrances, you need to have these kind of gates that can either you manually enter, you manually lock in that are active, or passively open up. So we're not done. There's still different types of flood protection. Should we have wet flood protection or dry flood protection? What are those? So what is wet flood protection? Excuse me, what is dry flood protection? Well, what dry flood protection is not is just lifting things and getting them out of the way. It's actually going and doing some of what I've shown some examples up to this point, which is just prohibiting water from getting into the building. So you can have an active or a passive system that prohibits water from getting in, so the building inside remains dry. That's really dry flood protection, is you're protecting it so the areas of protection are dry. Here's another example of dry flood protection. Do you see anything here that looks like flood protection I've shown you so far? Not really. This is in the Texas Medical Center, and there's actually a berm that goes off on the side over here. And these steps right here are serving as the flood protection. They're raising the elevation of the flood to prohibit the floodwaters from getting in. It's passive. You don't have to activate anything. And it's dry because you're preventing water from coming in there. You're not letting the water come in. Now this slide gives it serves two purposes for me. One is it's showing an example of active flood protection. You can see this is one that you have to go and physically go and lock in. It is dry flood protection because it's built to go and prohibit water from coming into the building. And at this time, what we're doing is we're testing that flood door. And so we're going and putting up a membrane on one side and then flooding it and allowing the water to go in there to check the gaskets and make sure there's no water leaking in from anywhere around of this flood door. For every flood protection measure that you design, you need to go and make certain that you test it as well. So what's wet flood protection? We know dry is to protect it and keep that building dry, not let water come in. So wet flood protection means you're letting it get wet. Now, I don't have a lot of fun pictures to go show wet flood protection because I'm an engineer and most of wet flood protection really is architectural. You're going in and you're making the building itself, at least on that lower floor, something that's designed to allow floodwaters to come in, and then you just hose it down, mop it off, and boom, you're back in business. There are some other things you do need to think about, though, when you're doing wet flood protection, because if you've got electrical outlets here on the bottom, well, those aren't going to work if they get wet. So there's some different designs you can do to allow them that way, or you go and you raise them and you just have them at a higher elevation, higher than your design elevation, or you just allow that system just to go and short out, no problem. Have that system separate from the rest of the building, so the rest of the building is still able to be active and functioning during that storm. It's just that lower level isn't functioning. And it also includes raising sometimes your mechanical equipment at a higher level. All those things this civil engineer doesn't do because those are all inside the building. All right, so what should we protect? Well, really anything the client wants. They come to you and they say, I need to protect this. Okay. Typically with industry standards, what I'm saying, what I've seen most of the times is you're protecting building structures, you're protecting the mechanical and electrical equipment and emergency power. Those are the things that we're trying to raise up above the flood elevations. And we'll get into what those flood elevations are in a little bit. But we're trying to get those above and out of any type of flood risk. And then, of course, we figure out ways that we wish to now flood protect it. Do we want to wet flood protect it, dry flood protect it? And you can see all the different questions that we have to answer. And some of these questions we ask the client because dollars are associated with these various choices as well. Now now that we know the different types of flood protection, now you need to go and perform a flood protection study. Your client has hired you to go and flood protect their building. They're not an engineer. They don't know all the things about it. So you help bring questions to them. You bring your expertise to them to help them better make informed decisions. And those informed decisions, of course, depend upon dollars as well. If you want to, we ask questions and say, okay, if you answer it this way, it's going to cost this much. If you answer this way, it's going to cost this much, and so forth. Depending upon each site, it always changes. And so we're trying to go, the end result is for the flood protection study is to go and, well, let's get to it. Here, we're trying to go and determine, well, what's the reason? What are the concerns for the facility? So client, why do you need flood protection? Have you had issues before? What were they? We're trying to better understand, hey, if you've been through a flood event, how'd the water come in? We can go and determine a whole lot better if we've known that it's been flooded before, so we can go and determine ways that it's occurred. And so it's always, it's not best, but that always helps to go and know if it has flooded before. Great. How high, what happened, what did it do, how was the building reacting? We've had some instances where floodwaters rose up and came into the entrances. It could have gone through the porous brick, but because the water it rose and fell so fast that it just came into the entrances, but it didn't have enough time to really sit up against the brick and slowly seep in. And so there's a lot of things that we're trying to go and understand. Is there history of flooding at this particular site, this location or area? Is it required by insurance? If it's required by insurance to go and do this, and I'm working on a few flood protection projects right now, that the insurance company came to that building and said, we have determined that you have a flood risk at this location. You need to go and provide flood protection. Well, we need to make sure that we provide flood protection that meets the needs of that insurance company, because you don't want to go and spend all the money for the study, the design, construction, only to find out that it's just a few inches lower than what the insurance company needs. So you've always got to go and ask these questions. Is it a critical facility? And we use this term belts and suspenders. So is it a critical facility like a sheriff's office, a hospital, that you might need a backup type of flood protection? So how critical of a facility is this? So we know different ways to really make certain that we're providing a belt around your pants, but we're also providing suspenders to really make sure that those pants don't fall down. All of these things, and now your knowledge of the different types of flood protection, that all comes together in the flood protection study to determine what is the optimum flood protection for this specific instance at this specific location. Because again, the constraints always change and it's always different. So that's where we as engineers need to look at all those constraints to determine what is the optimum flood protection system for that site or that location. There are always going to be code requirements. So you need to understand the code that's associated with that location as well. and make sure to design and meet those code requirements. And again, I was mentioning there are just various constraints. Now, you always need to pay attention to the elevation of the building, of the areas around it, and the elevation of the floodwaters or floodplain. So let's go and jump into that. In your flood protection study, you're trying to go and set what is the right flood protection level. So if you're in the floodplain, well, let's pull up the floodplain maps and let's take a look and see what are the elevations. So you can see this is an example of one area that we were going and performing a study. And there was, this area is, depending upon where you are, you could be in the 500-year floodplain, which is this green area. You could be in the 100-year floodplain, which is in the blue, or you could be in the floodway, which is here in the red area. Depending upon where you are, and also each of those have their own specific elevations. So most folks know there is a 100-year storm, and there's a 100-year storm elevation. We go to FEMA. This is pulling from the FEMA site, and at specific locations, you can go and determine what is the 10-year flood elevation, what is the 50-year, 100-year, 500-year elevation. And you can see as you go up with the extremity of storm, it goes from 47.26 feet to 58 feet when you go from the 10-year to the 500-year. So you need to understand what type of storm and what elevations should I make sure to, I know that's coming in here. Then I try to go and use that information to determine the proper flood protection elevation. And here we are trying to go and determine the proper flood protection elevation. So there are some industry standards. And I'm showing in the background here, any city, they're going to have their own design criteria manual. So you always want to go and design per that, but you also make sure that you're designing per FEMA's manual as well. Sometimes the two don't say the same thing, and you always err on the side of whatever is the most constraining, what requires the most, you design for that level. So we're trying to go and understand, well, for non-critical structures utilities, there's particular criteria and requirements for them. FEMA requires for non-critical to be 100-year storm plus 1 foot. Critical structures, 500-year plus 1 foot. But then there's also the local requirements I was talking about. And the reason I'm showing the City of Houston one is because just them as an example, currently you're designing for a non-critical, it's the 500-year elevation plus 2 feet. And for this is actually in Houston, we're setting the finished floor elevations to these elevations. So these would be the minimum that we would be setting for our flood protection. But these again are minimums, and we can work with our clients and say, do you wish to go and do a little bit more? And here's a little hint that we often do. When there's a requirement, say with the insurance company, FEMA, or the individual municipality, if they require you to go and design to a particular elevation, we're going to design in at least an extra inch or maybe 2 inches. Not because we're just trying to go and get a little bit higher. It's because we're trying to go and make certain that if the contractor, they do have some levels of tolerance. So if you design something for this and they just slightly go and construct it just slightly lower, is that an absolute failure? No. But you need to go and give the contractor some level of tolerance so that it doesn't have to be exactly at this elevation. So we bump it up an inch or maybe 2, just to make certain if they don't, it's not a failure and they don't have to rip it out completely and reinstall to get that extra ½ inch or whatever they might be off by. This is a site that we've recently finished the design for the flood protection. And the flood protection, this is a school. The flood protection level actually is not at this red band, but it's actually at this red band. And that one is about 8.5 feet high. It's a significant amount of floodwaters that have flooded this school before, twice. And we're making certain that it's not going to happen again. And so that flood elevation, as I've shown you, it could vary even on the site. At this school, in the front of the school, we're designing for 8.5 feet flood elevation. In the back, it's only 3.5 feet. Well, why is that? It's because the back of the school actually is higher in elevation than the front of the school. And there are some stairs inside the school that you wouldn't know just walking around. So the design of that flood protection is a little different. And it always depends upon the elevation around the building. So we're going and doing our flood protection study. What are the things that we really need to go and look for? We're walking around, we're taking photos. One thing you need to do is identify points of exposure to the facility. So that's points of penetration. So here's an example of a mechanical and heating ventilation coming in, and that's a penetration coming into the building. Over here at this location, in this area, you've got your what I'll call appurtenances. It could even be a yard hose spigot that you just plug your hose into. Anything like this. And here you've got your louvers for ventilation for the building. All of these are ways for water to come in. Remember that last slide I was showing to the elevation that we were flood protecting? There's that red band again. So if the flood waters did rise, they could come in, and on the backside of these, water could start coming into the brick at that, or water could easily come into the mechanical louvers at that, or even up here where there's the electrical line coming in, that penetration through that brick is another way that water could come in. So we're trying to identify all of those as you're going and looking around the perimeter of the building. And of course, there's the obvious building entrances. Each of these, they require different solutions, different ways to flood protect them. And you just can't go and put a giant 8.5 foot wall in front of these entrances because now nobody can walk in there. So maybe that floodgate, that rising gate that I was telling you about, could be a potential solution for this. There are other ways to go and do it as well. Now, that floodgate, that's one that is a passive solution, but they have another one they call flood logs. And you put up a system that it's considered like two poles sitting side by side, and somebody's putting in aluminum logs, and aluminum because they're light, and they have rubber gaskets. And those logs, you put those in, and now that entrance is protected. Now it's active, so somebody has to be able to know where it is, have the keys to that locked room, and hopefully nobody has stolen those aluminum flood logs. We found time and again that over years, somebody will take those flood logs and steal them because it's aluminum, easy to recycle, and you've got a whole lot of it. So you need to make sure if you're choosing an active solution that it's one that you can readily be able to activate, and you need to make sure that it's there when you are activating it. And so there are different ways for this water to come in. I didn't talk about the brick. I did earlier, but brick itself can be porous and water can come right in. Same thing with cinder block. Cinder block, very porous. So there's other ways that I've done site level flood protection, but there's other ways that you can also go and do flood protection. This is not to protect your building specifically. This is to go and stop you from being in an area that is likely to flood in the future. So now I'm going to go and talk to you about early warning flood system so that you know in advance of the storm what's going to happen and what to go and expect. So this is an advanced warning system. What it does, and this is really neat, you go and you have a system, a model that ties into the National Weather Service. And National Weather Service, 7 days in advance, says, hey, you're going to have some pretty big weather coming in your direction. And right now, we, the National Weather Service, predict that at this time, this unit, you've seen it on Weather Channel, the Doppler radar, the future forecast. That's the same thing. They can forecast 7 days in advance and show you the future Doppler. Well, that's kind of what we're using. So we're connecting to that. And so we can go and tell a municipality or somebody, hey, this is what's going to happen based upon National Weather Service. Right now, we predict that the floodwaters are going to reach these levels at these locations. So now you're looking at an aerial and you can see this subdivision. Well, this subdivision is going to get all wet. This subdivision is going to remain dry. So now if you're at a municipal level, you're saying, all right, so where should I close the roads to stop people from traveling in advance of the storm, in advance of the flooding, because you've predicted and you've been able to predict based upon the models of the future rain coming in, we can predict what the flood waters are going to be. So you can do it city level, campus level, and you could do it at individual site level, but often those are more of a macro level. All right, so that's way in advance of the storm. Then there's early flood warnings. So now we're, instead of 7 days in advance, 6 days, 5 days, whatever, you're in the storm. The storm is just starting. Now we can predict based upon what's fallen, what the floodwaters, how the floodwaters are going to respond. Because as you know, when you're looking at, say, this level, this is a major area. Well, when it rains, it takes time for that to get through your lot, through your streets in your neighborhood, through all the pipes and everything in the neighborhood, and discharge out into the nearby stream. And then that near stream slowly goes downstream and more water is coming into there. Well, that's what this is doing in advance of all that time for it to happen. While it's real time, water is happening. We're going and tying in the actual rainfall data that's happened, rain gauge data, flood gauge data information that's in the streams, connect those two into a flood model. So we're really understanding what's the hydrology, understanding all the storm that's happening, put that in, design that flood model so it presents you slightly in advance. So it gives the emergency operations people real-time information before the floodwaters get all the way up to elevation, what to expect at this time. And as you guys know, storms change. National Weather Service, they think the flood's going to come in your direction, and all of a sudden it changes. I remember with Hurricane Ike, we thought that it was going to go into Corpus Christi, we pretty far south of Houston, and they were saying that for days. And then just the day before the hurricane hit, the model track changed, and now it's going to hit Houston. Those things change, so that's why you need to have sometimes this early warning flood system. So while it's happening, you can go and predict and get that very important information to those emergency management people to go and activate the things that they need to keep the public safe. And so as I was calling it, real-time flood event modeling. There's another thing that you can go and do. I'm sure folks have been in areas where they've seen these, and it lets you know, hey, this is right now, looks like this is not a foot high of floodwaters. So you could probably drive through there, but once it gets up here, hey, that's letting you know, don't drive through here because your car is going to get flooded. Well, this system, we go through and we use the flood gauge information at specific locations, and we use floats. And this is just a simple float like you would have in a pump station. And the floats go up and they activate. And so when the floodwaters get to a particular elevation, they activate lights flashing so that somebody doesn't have to go out there and kick them on. And somebody doesn't have to go and put them on way in advance just so that they can have them on and get away before the floodwaters actually rise. because the public doesn't trust them anymore. So this is a real-time system. So as the floodwaters rise, now we're activating and trying to let the public know, hey, this is an area, do not go over here, because we've got these gauges set up to warn them. So there's a number of different ways that you can go and help the public understand, either protect your building or warn you in advance so you don't get in the areas that you could go and risk your life or your family's life. So here's our summary. Hopefully, you guys will agree that I've given you a definition of what resilience is and a definition for flood protection. So we now have defined those. We know what kind of facilities should receive flood protection or typically do, because what facilities receive flood protection, the answer was whatever the client wants you to go and do. But the typical facilities, I went through all the different types that we typically go and flood protect. And now you know all the different types of components and things that come involved in the flood protection system. And you've got your passive versus active, you've got your dry versus wet. And now you know all the things that come into the flood study to go and determine what is the optimal solution for that specific location. You now know how to go and make your determination on what your flood elevation should be at that location. And now you know the flood elevations, they can also change because of just the topography on that site. As I gave you, there was the example of the school. They had 8.5 feet of flood protection on one side of the school and just 3.5 feet of flood protection on the back side of the school. Now, those elevations happen to be the same as far as true elevation, but the height of that flood protection was just 8.5 in the front and just 3.5 in the back, because the back was higher in elevation. Again, you now know the dry versus wet flood protection and active versus passive. I showed you that example of how we make sure to go and do testing, commissioning for our flood protection devices that we do design. We don't want to just hope that they work. We need to make certain that they do work, show the client that they do work. And then during that time, we also go and show them how to maintain that. What works today doesn't mean it's going to work 10 years from now if you just close that door. You need to go and continue to maintain and make certain they're not rocks, roots, things in the way that could affect you being able to close that, or things in the way that could affect that floodgate from properly rising. And so you need to continually maintain that. And we're always providing that information to our clients to make certain they're doing that maintenance themselves, but we're going to do the commissioning, the testing up front after the construction was completed. And of course, you know all the flood study components now of what we're looking to go and present to our client to help them understand what we feel would be the best flood solution for them. And now you've also seen flood warning systems. So this is not flood protection, this is just flood warning. So you've got advanced time flood protection. And so you've seen where we tie into the National Weather Service, and based upon their predictions of where the rain is going to be and how long it's going to be across an area, we can predict where the flooding is going to occur and where it's not going to occur. Then we can also real time, so when that storm is happening, we can go and predict as eventually as that stream receives the rest of the water and starts to go downstream, we can predict real time what's going to happen in the future, so that the emergency operations group can go and prepare for that and get all those things and make sure to keep the public safe and out of those zones. Now, my next slide, I'll always end whenever I'm doing presentations to students. I had a great professor that it was an economics professor, and he went and he used this term: if you remember nothing else from my course, I want you to remember this. And then he went on about something. For me, make certain to go and get your FE, take that, get it as soon as you can. And then when you graduate, go and take your PE exam, get the years of experience that you need, take that PE as soon as you can. Don't wait. Even if you go to a job that it might not be needed for that particular job, you might hear from people, because I've seen this, you might hear people that might be the devil on your shoulder. You don't need to do this. Don't worry about it. You don't have to sign anything. So you don't need to worry about taking that test. You don't need to go through that. That's a pain so long. Do it. Because if you look, even say municipalities, state, federal institutions, they're not designing, they're not signing plans. But if you look at the heads of those organizations, you'll often see the name of the person, comma, PE. So make sure to go and do that, because that's going to help you advance your career. And it's a whole lot harder to go and do that later, well after college, than you guys right now. I'd hate to go and take that right now. It'd be a lot harder for me than I think it would be for you guys. And so that's why I'm trying to warn you in advance. Please do this. I want to thank everybody, all of our sponsors.
Thank
And
you,
Heather, I
Doug.
think this is where you come in.
Yes, and we will take any questions. I don't see any in the chat, so now is your chance, if you've got any questions, to add them to the chat. We've got a few minutes here before we wrap up.
Or maybe the presentation was just so succinct.
Could be, it was that informative. Well, I'll have a question for you, Doug.
Yes, ma'am.
So do you know what have you seen as far as costs for passive versus active flood protection? Is there a difference in cost, significant difference in cost, or does it all depend on which type of protection you use?
More often than not, your active is going to be cheaper. That flood log example that I gave you, that's one of the much cheaper type of examples that you could go for entrances, like the double door entrance that I was showing for that school. You could go and put in your individual flood logs, and that would be a much cheaper solution than the floodgate solution that I was going and mentioning. And it really depends upon the client. What's your appetite? Do you want to go and pay a little more money to not have to ever worry about when the water comes in, to have to activate that? Or, you know what, I've always got staff on hand 24 hours, so no problem. I can go and have somebody go and activate that. I don't need to spend that money because we're always going to be here. That's a decision for the client to go and make. But yes, normally you're passive if it's one of these type of situations where it's swing gate opening. But on the flip side, I showed you the example of the students and the professors sitting on those stairs. Well, that's a passive system, and it's cheaper than an active system. So it can depend, but in general, you're going to have the passive is more expensive than the active.
Okay, and we've got two comments in the chat, and one is related to Harvey. So was there a final determination or opinion regarding the timing of the Barker flood control floodgate opening during Harvey? Should it have been opened earlier, or was it possible to determine in hindsight?
Oh boy, that is a political football. I don't have any, I'm not specifically active with that. That's more, if you were, the best person to ask that question would have been Andre Salazar, who presented, I think, at 11 o'clock on floodplains. And that's much more of a floodplain, higher level or macro level type of question than it is for an individual site. So I don't have an answer to that one, but I know that there are a lot of litigation cases that are occurring right now as a result of that. I'm not sure that there's been a final determination. I've not read anything in the paper as of yet.
Thanks, Doug. And Sean just has a comment. He's just a little concerned about flood doors being overwhelmed. He saw a video of flood doors failing during Allison in the Houston tunnels. So those waters must have pushed through those walls surrounding the flood door.
That's what's fun is you whenever you're going and having flood protection, make sure you're going and utilizing the proper design mechanisms. One of my structural cohorts, I'm on the civil side, he's on the structural side, and we work together because, as you can see, these are not just purely outside civil type of flood protection. That you're going to have to go and connect with the structure also. I can't say his claim to fame, but he has actually put a few flood door companies out of business because they claim to do certain things. And because we do that commissioning at the end of our construction, he goes in and says, look, it's still not operating the way it needs to. It's still leaking. You need to go and replace this. And there have been times that they just couldn't fix it. Then they had to go and pay for all of the new construction for somebody else to come in, or they've gone bankrupt. So make sure that you're connecting with the engineers who have that expertise. This shows why you need to go and vet your engineers. You shouldn't go and just hire somebody. Oh, you're an engineer and you should understand how to do this. It might be your first time, because they might not know which are the proper companies to go and use, and might not think about the commissioning and how to go and do that testing. So with the ones that we're designing, because we're commissioning and testing them in advance, that won't happen.
Thanks, Doug. So we have no further questions. So I'd like to thank Doug Conan for providing this presentation, and thank you all for your attention. Please visit the event schedule in the ASCE Texas Student Symposium Attendify app to review the additional sessions you'd like to participate in next. Some of those options include the upcoming technical presentation titled Water for Texas, Water for the Future, presented by Kathleen Jackson, board member of Texas Water Development Board. We also have a power skills presentation coming up titled Email Etiquette, presented by the ASCE Texas section staff, Lindsay O'Leary and Mike Sosa. And of course, the career fair. It ends at 3 p.m. today. This is the final hour to schedule a meeting with one of the recruiters. Don't miss out on your last chance to meet your potential future employer. There are 18 companies participating, and many have several offices across the Texas-Mexico region and beyond, so check it out. So thank you everyone for joining. That concludes this session.
Thank you, everyone. I'll now stop recording.